Hello, everyone. I'm Julia Chen from ABM Nano. We are a manufacturing company here in Houston, Texas, providing high-performance materials. I think we may want to zoom in a little bit, zoom out a little bit. Yeah, perfect. Thank you. So we are a high-performance materials manufacturer from Houston, Texas. We have with our patented nanotechnology. Today, I want to talk to you about our current focus, one of our current focus, which is the solid-state battery for the electric vehicles. Based on the market analysis in 2020 for the solid-state battery, there's about $62 million value for the market, and it's going to grow dramatically in the next few years. Some of the analysis you can find are billions of dollars and they're evaluated. So it's going to grow. For the next page, please. We're going to talk about, there's obvious reasons why we wanted to have the solid-state batteries. And it's going to be the next generation, the electric vehicles. Because of the flammable electrolytes in EVs poses severe safety concerns of catching fire and explosion. And we have cars destroyed, people were killed from the fire, and we want to stop that. We will develop this non-flammable solid electrolyte. And it's for the solid-state battery, and the battery is safe and fast charging, and for the long mileage, and which gives you, eventually, it's going to give you the days of, battery that stay, you don't have to recharge again. And that's our goal. But currently, the market, if you can find any solid-state battery supplier, it's still, there's some issues that they're challenging, and they cannot reach the solution for a reliable and scalable technology. Next page, please. So the good news is ABM Nano, we have developed this nanotechnology that gives you the solution. We wanted to replace the flammable liquid electrolyte by the solid electrolyte. And you see that the key problem is that solid electrolyte are centered from ceramic powder. And by the way, we are expert of powder because we have manufacturing powder and its advanced materials in the past 15 years. And we sold our business, one of our business in Montreal in 2014. And back then we've already delivered tons of powder. So we're the expert of powder, especially ceramic powder with our nanotechnology right now. So centered ceramic powder to high density electrolyte using lower temperature and less time has been a huge challenge. Now that ABM Nano can offer the nano-sized lithium solid electrolyte. The difference is that the liquid electrolyte that we can offer the solid electrolyte that has high efficient volume production with low cost, and it's going to give you the high ionic conductivity, high energy density, and the next thing is most importantly dendrite free, which gives the safety. There's no explosion ever again. Next page, please. To compare the difference, on the left, you can see the current supplier. They are supplying the smallest particles they can offer is 5 to 7 micron size, which is going to be a low energy density and causes the dendrite issues, which result in the explosion. To the right, you can see ABM Nano. What we can offer is 50 nano particle size, and it's 100 times smaller. It's going to give you high energy density. We've already produced this product and patented it's LZO powder. So it's going to be 100 times smaller, and we have fast, efficient processing capability for volume production. And you wanted to compare, basically you're trying to burn the wood log and versus you wanted to burn the sawdust, which is very easy. And it's going to be at least 20 times energy saving for the sintering process. And it's going to be thin film manufacturing, of course. Next page, please. Next, we wanted to show you, this is the competition. The current market, we have the QuantumScape and Solid Power. These are the two companies who are already in stock market and raises billions of dollars for develop the solid-state battery. But they still are facing lots of the technical issues. We believe ABM Nano would be able to partner with them if they're interested, and we can solve the problem, the fundamental problem for their. And they're trying to make the thin film and all different kind of technical problems they wanted to solve, and ABM would be able to working with them. For the next page, please. Now, here's the endorsement from this is advisor from ABM, and Dr. Steve Harris is professor from Berkeley Lab. He's commented that ABM Nano is the only technology that is going to help reduce the energy cost of a solid electrolyte, which is going to be commercially viable. And Professor Doherty from UIC commented this is going to be a major contribution. We're going to continue working with Berkeley Lab and Penn State and achieve the goal for the solid electrolyte. In the middle, you would see a 15 nanometer powder that's produced by ABM Nano. Next page, please.
30-second warning.
Yes, thank you, Richard. So here's the result from the experiment from Berkeley Lab and Penn State and UIC. All of their feedback are very promising, and it's showing that ABM is the only supplier offering the small nanoparticles of this powder. And Penn State, they wanted to continue working with us because this is the highest energy density they've ever seen. And UIC would show that very impressive dispersion from their experiment. Next page, please. So other than that, we are manufacturing all different kinds of powder with our nanotechnology. We have a broad base. We have the high entropy aniline powder for coating for Air Force, and we have thermoelectric powder, high purity silicon powder, all different kind of materials for different applications. So basically, ABM Nano is the expert team specialized in custom manufacturing high performance nanopowder. And we have lots of experience in the past 15 years. Next page, please. So here's what we're looking for. We're looking for $3 million, and we wanted to continue the research with Berkeley Lab and Penn State, developing the prototype. We wanted to achieve that goal faster, and the next step would be the commercialization for the product of solid electrolyte and solid state battery. Hopefully, we can partnership with those companies, which I showed above. Next page, please. And, in the next 5 years, if everything's going well, and we're going to have the IPO in place, having the investor on board with us. We're looking forward to working with anyone who's interested in solid state battery. Thank you very much.
Thank you so much, Julia. Questions from the panel? Go ahead, John.
Yeah, I agree with your statement that dendrites are a problem in solid state batteries. Do you have any data that actually shows that you've solved that problem? Because if you have, that's a really big deal. And that, those are some of the lingering challenges that QuantumScape and others are facing.
Absolutely. I understand that is definitely the key issue that we're trying to solve the problem. That basically it's the whole world trying to solve that problem. So that's why ABM is able to, using this nanotechnology, processing this powder, which nobody else in this world would be able to produce this nano-sized powder compared to the current supplier that is the 5 to 7 micron. And what we have is 15 nanometer. I will tell you that's what we have already achieved, 15 nanometer size, which gives you, imagining that is the highest energy density you can ever achieve. And with the density, of course, the dendrite would not be an issue.
But you sinter the powder, so the resultant material will not be 50 nanometers, right?
Right. Well, with the sintering, that is why we work with Berkeley Lab and Penn State. We've already achieved above 93% of conductivity, and we have some pretty good signs that shows that we have very good ionic conductivity. That's why the whole team is very excited.
Okay, thank you.
Thank you.
Go ahead, Tina.
I think maybe Han raised his hands first.
Oh, could be. I don't see him on camera, so he was.
Okay.
Oh, okay. Well, I can go first. Okay, it's gonna be my quick. A great solution, by the way. Thank you.
Thank you.
Just quick, yeah. So quick question here. So your solution is how is it different from we've seen another group working on something similar solutions. Of course, many groups are doing that, but one group I think they're from Harvard University. They're using the multi-layer design to solve this problem. How your solution is different from theirs? I'm just trying to understand a little bit more technology side of it. Thanks.
Thank you for the question. I think I read a little bit about multi-layer. I cannot really answer on behalf of them. I mean, I don't want to undermine their capability or their solution, but from what I understand, we have talked to a few professors, and the problem is that it's always stay on paper, and it's never achieved the real goal in reality. And for ABM, we've already achieved that powder in 15 nanometer, which nobody else has ever made that size. And it's in high performance. That is a huge difference. And we're trying to really help the world to achieve the goal, because we understand a lot of technical problem is because that there's no one else can make that kind of size powder with the high performance result. And the nanotechnology with ABM, patented nanotechnology, would be able to help them. And that's why I was at the Ceramic Expo in Cleveland, Ohio, showing everyone of our high entropy powder and the sodium-based powder, the battery powder. Hopefully more and more people understand we can help them.
Awesome. Go ahead, Tina.
Julia, so help me a little bit on your IP. So my understanding is that solid state batteries, a lot has to do with chemistry as well. So is your IP covering just the method to reduce the particle size, or does it also, cover the composition of the matters? Because if it just covering just the particle size formation, then it means that you will always have to work with other companies, right, in order to commercialize the solid state electrolytes. So help me a little bit here.
Thank you, Tina. That's a very good question. I get that question a lot. And basically what we can do is a process of mechanical alloying. So it's not just about reduce the powder. Reduce the powder significantly is certainly one of our advantage. And that's also very important. Imagining nanotechnology is basically giving you the option of having everything smaller and lighter and thinner. And at the same time, it gives you the high performance. I keep talking about that because mechanical alloying is basically giving you different materials combined together and recreate a new material for you. So, so it's not just about A plus B plus C material result. It's a new material that we are creating.
And for the solid state application, is your IP covering the composition of the matter?
Yes, we cover the composition as well.
Thank you.
Awesome. I think we have time for just one last question. Yoav, you want to take that?
Yes. A question about your business model. Are you planning to be manufacturing batteries, or just providing the technology for battery manufacturers? Because if you're going after manufacturing batteries, that's hundreds of millions of dollars in investment in building capacity, etc.
Yes, thank you. That was a very good question. Also, we have thought about this. We have a lot of discussion. The thing is that there's a lot of patents involved in this technology. So battery, company like Samsung and many other companies in South Korea, in Japan, in China, they have lots of patents involved, and in US as well. So we wanted to really partnership with those companies to really produce a solid electrolyte. We wanted to be the one who's supplying the solid electrolyte, which is the key part of the solid state battery, because right now people are providing the liquid battery, the solid electrolytes, which is the key issue of the, the fire. So we wanted to solve that problem. And for the rest of it, I mean, we can make cathode as well. Basically, the whole part of the powder of the solid state battery is made of powder. And we have that capability producing a nano-sized powder. So the next step would be the sintering, and it would be the thin film, and goes to the battery.